One of the things you'll notice with your program that you've changed between the user input example from 1.1 to validation in 1.2 is that we've now added a considerable amount of source code to our solution. So, if we now move to the next directory and have a quick look at our source code, we will notice that our program.cs is now becoming quite long. Now obviously if you wanted to ask the user for 2 people to be entered, one of your options would be to repeat all of this code a second time, copy and paste it underneath. Obviously that's a pretty ugly solution, especially if you would want to change that to 3 people, or to 2 people, 3 people, or 5 people. So obviously that's not a technique that's going to work long term. So we need to do something a little bit more elegant. So in this case, it might be something like placing this piece of data, this piece of source code inside a loop that requests that information. So what I would suggest that we need to do is we need a variable up the top here. Those variables are going to need to be blanked each time we use them inside the loop, otherwise it'll carry over data from the previous time, so it makes sense that we would want to do that. In this case, because we're going to reuse the valid bit each time we go around the loop, we are going to want to reset those each time as well. So let's move these out of the scope of the loop that we're about to create. So let's move them outside, off the top here. So the first time the program runs, it's going to create a place to store these variables. So, the kind of sensible way to do this, logical way, is we want to enter person details. So, for argument's sake, let's say we want to have a number of persons required, and that is going to be a new int. And I would suggest that number of persons required might be, in this case, 3. So the obvious thing that stands out is we're going to want this code inside a loop, and we're going to want to go through it 3 times. So what we're going to want to actually do is start about here, and after there's a success of a person and we've printed out, we're going to end about here. So all of that is going to need to be wrapped up in some kind of structure that goes around multiple times. There are different kinds of loops in different programming languages, while loops, do while, for loops. There's a whole bunch of them depending on the particular language. My personal preference is the for loop. So in this case, I would suggest what we want to do is we're going to want to indent all of this and wrap it around in something. So we're going to say for something, we're going to do this loop. So we're going to move this bracket here down to where we're ending. So we're going to highlight all of this and indent it in one block, like that. So this is our ending point, and we are tabbed into spaces 4, column 13, 413, so we're at the same level of indentation, which is nice. Oops. Just for nice neat structure. Okay, so now we have something wrapped around our for loop, wrapped around the code we want to run 3 times. So in this case, we're going to say for integer persons, let's say number of persons entered equals 0. So we're going to start off with the number of persons being 0, and we're going to say every time one of them is entered, we want to make the number of persons entered equal the number of persons plus 1. There is shorthand available for doing this. Sorry, that's the wrong order. We want to say if the number of persons entered is less than or equal to, also less than the number of persons required, we are now going to want to say number of persons entered equals number of persons entered plus 1 when the loop is finished. Now there are ways of shorthanding this. This particular nomenclature is one that is often abbreviated as this. This is very, very common in C and C# and C++. That in fact is probably the way you'll see it almost universally in C-based languages. So here we start off with the number of persons being 0, the persons that we've actually entered, every time we get to the bottom of this for loop. So every time we get all the way down here to here, that number will go up by 1. So this will, when successfully entered, go around 3 times. So let's save that and run it. Now if I've made no errors, this should work successfully for us. Person name. Now let's call them person, let's try and spell it correctly. Person 1, age is 111, 111.11. Okay, so that did not work exactly as we expected. Now remember when I said earlier on that we needed to reset these values. What we need to do when we get to the end of the first loop and we've printed out a valid name is say person name is valid equals false, because we want to re-trigger that logic that asks for the values again. And we also want to say person age is valid equals false, because the person's age needs to be re-entered. Person bank balance is valid, also equal to false. So the only time these get set to true is after the data is entered inside the loop. So this time I believe we should be good to go. So person 1, age 111, so that's one person. Person 1, successful. So if we now did a person 2, age 22, 222.22, we get a second person. Person 3, 33. Let's show you something a little bit interesting here. The comma in here can be interpreted by the try and pass element of our function on the float data type. So if the string that's read in is considered to be a valid string for that data type, including things like delimiters and things like that, they can actually be processed automatically. This is not something that you can rely on without automatically testing, but it's an interesting side note. So in this case, the comma is taken out, and the $33,333 is processed. So here we have person 1, 2, and 3. Interestingly, when we put the this data out to the console, it's the same as it was in the non-looping version of the code. But it would be quite common when you're doing something like this to be able to show which person you're processing. So inside our for loop, we have access to these variables, number of persons entered and the number of persons required. So the persons required is declared, outside in the main program. This number, this integer here, is actually declared in the constructor of the loop and can only be used inside the for loop. But the interesting thing for us is that we started off at person 0 and we wanted to loop 3 times. So in effect, we are looking at person 0, 1, and 2. So if we wanted to say you entered person and then change this to 0, so these are just the placeholders for these variables. So if we were to now add an additional persons entered value here, we would expect to see this value read 0, 1, and 2, which would give us this this string, a different string for each person that was entered. I'll quickly bounce through this and enter 3 people's worth of data quickly and show you how this works. Person 1, 1, 1, 1, 1, 1. Person 2, 2, 2, 2, 2, 2, bang. So, person 3. So you notice here, you entered person and the person number is 0, 1, and 2. So of course if we want this number to be sort of the human readable version rather than the 0 based count of the times we've gone around the loop, we would just add 1 to this and run this program again. And now the person 1, 1, 2, 3, 1, 2, 3, 1, 2, 3, and now you have person 1 at the start instead of person 0 at the start. So of course if we did this all the way through, you'd end up with person 2 and 3. So that's how you create a loop and how you determine how many times you've gone through the loop. There are also other loops you could use. So for example, you could set your, you could have a while loop. So you could say, we want to start our loop here, the number of persons entered equals 0, and let's change that to, no, let's stay at 0. Most older languages tend to use 0 as the starting point for counting array positions, indexes, and just general counting practices. It seems to be the way older programmers do it. Personally, it's the way I do it. It works like this in PLCs as well. So it's conceptually, I prefer to use 0-based addressing because the 0-based addressing is going to be much more consistent when you think of in terms of PLCs later on in your training. Instead of having a for loop here, let's do something slightly different and say while the number of persons entered is less than 3. Oh, and we don't want to hard code our 3. We'll use it from a variable so we can change it at some point if we wanted to. So the good thing that happens here is this while something is less than something nomenclature is easy to understand, easy to read for a novice. The downside is, and the most frequent error I've ever seen using this, is that you need to increment the number of persons entered manually, and you need that to happen at the bottom of your loop, which is where we ended. Number of persons entered, again with the plus nomenclature, which is the number of persons entered equals number of persons entered plus 1. So this is what's called a unary incrementer. So if we save that and we ran it, clear, this time we would have a while loop that works. Person name, person 1, person 2, person 3, persons 1, 2, and 3 printed out to the console in a while loop functioning in the same way. So different loops can be used, whichever loop feels the most appropriate. For example here, while something is not equal true, makes a lot more sense. You couldn't have a for loop. You couldn't say for person is not equal valid. That doesn't really make sense, both when you read it and in a programmatic sense it doesn't make sense. So while loops, for loops, do while loops, there's multiple ways to skin a cat. Whichever one feels right is generally the right approach. Personally, I default to the for loop, where when any loop can be used, I like the for loop because there's no chance of forgetting the unary incrementer or the incrementer at the bottom of the loop. So that's how you accomplish looping.